So in this video, we're going to talk about how to convert between degrees and radians and how to find the measure of an arc length. So to convert an angle given in degrees to radians, you're going to multiply by pi over 180. So for example, if we want to convert 330 degrees to radians, we're going to take 330 degrees and we're going to multiply that by pi over 180. So since we're basically multiplying fractions, right, you can put this over 1. We're going to simplify whenever possible. So for example, 3 will go into both of these, right? So I can divide this by 3 and get 110, and then I can get 60 here. Then I can also divide both by 10, right? So I'm going to get 11, and then I'm going to get 6. So I have 11 pi over 6 radians, okay? That's going to be the equivalent angle measure. So you can also go the other way and convert an angle given in radians to degrees by multiplying by 180 over pi. I actually like to use a mental math shortcut on these ones, and what I do is I convert the pi in the original angle measure to 180, and then I just simplify. So let me show you both ways. If you want to multiply by 180 over pi, you're going to take 4 pi over 3 and multiply by 180 over pi. So what will happen here is the pi will cancel, and then 3 will go into 180 60 times, right? So we can just reduce that. So we have 4 times 60, that's all we have left, and so we have 240 degrees. If you want to use the shortcut, which is what I like to do, I just take 4, and then instead of pi, I'm going to turn that into a 180, and I'm going to put that over 3. So you can see 180 over 3, well, that's going to reduce, right? So we have basically the same thing, 4 times 60, which is 240 degrees. So another thing we talk about in this unit is the central angle. A central angle of a circle is an angle that has its vertex on the center of the circle. So you can see here in this diagram, angle O is a central angle because its vertex is the center of the circle. So what happens is if you know the measure of a central angle and the radius of the circle, you can determine the measure of the corresponding arc using the formula S equals R times theta. So what S is going to represent here is the arc length. Okay, and that's what's shown here in this diagram in blue. So if you imagine if this was like a piece of string and you were going to unwrap it and measure its length, that's what S is. R is the measure of the radius, and then theta is going to be the angle measure that's in radians. Okay, so very important to remember when we're using this formula, theta is always going to be in radians. So let's imagine we're solving this problem. So it says a circle has a diameter of 12 centimeters. So whenever they don't give me a diagram on these problems, I always go ahead and sketch my own, okay? So we know it has a diameter of 12, and remember the radius is going to be half of the diameter, right? So we know that this radius here is going to be 6 centimeters. So then it says to draw a central angle FOG. So a central angle can be anywhere. Remember, its center is going to just be, the vertex is going to be the center of the circle. So let's go ahead and label it FOG. And then it says the radian measure of angle FOG is pi over 4. So we know that this is pi over 4. And now it's asking us for the length of this arc right here, right? So this FG. So we can use this very useful formula, S equals R theta, to determine the arc length. Remember, S is the arc length, and then R is going to be our radius, which is 6. And then theta is given to us. Theta is pi over 4, and since it's in radians, we can just leave it like that. So now, once again, since I'm working with fractions, I'm going to reduce. So this is going to become 3, and this is going to become 2. So we have S equals 3 pi over 2. And so that is the arc length. Remember, the units are going to be the same as the diameter because we're talking about the length. So this is going to be 3 pi over 2 centimeters. If you want to, you can convert it to a decimal by using your calculator. Remember to use the 3.14 for pi. So 3 times 3.14 divided by 2. That's going to be about 4.71 centimeters. Okay, so here it says that we have the radius of a circle O, which is 5 feet. So once I'm going to draw my picture. So here's circle O, and then here's the radius, which is 5 feet. Central angle AOB is across from arc AB, so let's go ahead and sketch that in. So here's AOB, and then here's our arc AB, right? The length of arc AB is pi over 12 yards. So on this kind of question, you want to be careful about the units. Okay, so it says pi over 12 yards, but look at this. This is in feet. So the quickest way to take care of this problem is to go ahead and convert everything to feet. So we're using consistent units. So I'm going to take that pi over 12 yards. And remember, there's 3 feet in a yard. So I'm going to go ahead and multiply that. And then this is going to reduce. So this is going to become now pi over 4 feet. Okay, so pi over 4 feet is the length of this arc AB. So now it's asking us for the radian measure of angle AOB, right? So angle AOB is that angle right there. Let's go ahead and call that theta. So we're going to use our formula S equals R theta. So we have pi over 4, because that's our arc length, equals R, which is 5, times theta. So now to solve this equation, I'm just going to go ahead and divide both sides by 5. So when I divide by 5, I basically have pi over 4 times 1 over 5, right? Because I'm multiplying by the reciprocal. So that's going to give me pi over 20. So that means that theta is equal to pi over 20 radians. And that is your answer. If you wanted to go ahead and convert this to degrees, remember you could use those formulas that we originally talked about. So you could do pi over 20 times 180 over pi, right? And then the pi will cancel. You have 180 over 20. And so that's going to give you an angle of 9 degrees.